I've also looked at the previous test, the effect, it's quite unique. Let's take it apart now to examine its internal workmanship. 1200 watt outer shell. Let's measure its dimensions. I've already removed this screw. So the size is 335. Height is about 70. Then the width, the top width is 16. The bottom is 2 centimeters wider. That's roughly at 1200 watts, is quite large for this size. Let's open the shell and look inside. On this outer shell, there's an iron block locked on top. The iron block is locked on top. This iron block goes through here, possibly secured by 2 screws under this sticker. 2 holes for handle installation, I think I saw in the manual. In the manual, it mentions a handle option. We'll ignore that for now. There are several prints here. These prints mark the film positions. The adhesive seems ineffective, just 2 strips. That's the thermal paste. The paste surface looks smooth, unlike the rough side. So in total, this is likely a transformer, 1155 transformer, and then here 443A fuses. And on this side, 425V, 2700 mF electrolytic capacitors, 200A ripple is unrealistic here. Here's an auxiliary power supply. This is an H bridge. There's a temperature switch and auxiliary power. This is for the fan. This is for the mask switch. Let's unplug it. They saved a connector opening directly from this port. This wire locks directly. Let's remove this too. No, let's remove this wire. Okay, and then here there's a voltage selector switch and another remote control port, and RCRC, maybe this far away. There's a switch function with 3 indicators. Basically this panel is like this, but look at this AC part. The bottom operation is reversed. I don't know why it's designed this way. Is it to make it easier to lock this screw? Okay, let's move this aside first. Then we'll take this board out. You see 3 screws, 4 screws, 5 screws. Seems there's another screw somewhere. No, it's gone. There's a mechanism here. Look at this side. He locked a screw here. Behind is plastic. Okay, we've removed this. Just powered on. Not sure if there's any leakage. There's a microchip at the bottom. Then here's a grounding terminal. We see this board has been taken out. It was placed like this before. Okay, it's placed like this. Let's take a quick look. This is the input terminal. No physical transformer. Positive and negative poles for 2 external power supplies. 2 guards are installed here. Maybe one for overcurrent protection, one for short circuit. This board is for photofilms. 3 photofilms on this board. These cards are empty, so it might be shared. Here it's 400 volts. Oh, this adaptation seems a bit off. Is it 1.4 perhaps? Well, 104S became 304. The output supplies mother inductor. These 2 connectors for UPS function aren't installed. This is for small earphones, small inductors. These 2 315V 680 UF capacitors should be in series. We've tested his bus before. It ran to over 550 volts. So we can only choose these 315V in series to reach 630V. hitting 630 volts. Here are 4 tubes, can't see the model. Let's see if we should take it apart for a closer look. The MCU model here is HTM. Looks like HTM32, hard to see. The small board seems removable. Let's pull it out and take a look. HTM32 is F. There are some OPA 4171 in the back. It appears to be this model. It's 2003 ULN, so nothing special there. There's a switch, these screws, and that plastic screw from earlier. Here are 4 low voltage 220 tubes. Capacitors, likely inverter caps. Output is 250V, 5W. Here's the power supply, 2 auxiliary sources. I made a DC-DC for these 2. 61520 power, 2 isolated drives. High temp volts and low end for isolated power. Oh, a 55 transformer with a slot underneath. Let's look at its winding method. Instant winding rhythm. Copper inside, coil outside with a barrier. That's about it. I cut it. Inside isn't yellow copper, but white. So this... Not sure what material this is. Anyone know? Here are 4 rectifier tubes. F encapsulated rectifier tubes. Nothing special underneath. Looks okay, a bit tricky though. Cross-sampling resistor is intense. Lots of winding, big circle. Wraps around this board, current sampling circles too. Seems to cover everything. So that's the whole power setup. Wonder if this EMC passed. Looking at the output here, few common modes, 2 Y caps. Input has 2 Y caps too. 2 more Y caps to ground, pose neg to ground. Very simple operation. Then the diffuse gas, it's not grounded, it's suspended in air. High voltage diffuse gas is suspended. With suspended high voltage gas, we can basically conclude its EMC has failed. Let's open this tube and check its model number. Oh, it seems stuck. I'll handle it. Is it loose now? This thing's tricky. Why can't I remove this rubber sleeve? Let's see. The inside looks reversed, it seems. So it might be a bit tough to remove. Got it off. The model number is K3011S. S-series? Wonder if it has separate high and low speed tubes. Interested folks can look it up. Now for the low voltage tube. Let's just disassemble it and take a look. IFB, IRFB. Four inside. For peak current of 220 amps, basically 4 to handle it. Each runs about 50 amps. Nothing special about the others. This rectifier tube has a soldered head. Okay, F2008. F2008C seems to be the model number. That's about it for the disassembly.